right, Clarence Cooper. Here we go. I got these problems for you. And an ingenious way of doing this is to videotape them and to send you the link to YouTube so you can watch it. Alright, so here I've got similar problems to the ones you have on the worksheet, so you can kind of put it together what we're doing to get the ones, and you can do 7 and 17 on your own and have that feel good feeling of knowing how to do them and getting them right. Okay? So, like once again, here I've got this compound or complex fraction, and I want to do the numerator separate from the denominator. So I'm going to solve this numerator first. Alright, so here I've got 3 over 5y, and this is 8, but really this is the same as 8 over 1. And our sub goal is to get the denominators to be the same. So in order to get this, both these denominators to be 5y, I have to multiply this 1 by 5y. And remember, what I do to the bottom, I have to do to the top to keep the problem the same, not changing it. So that's what it's going to look like. So now I know this is the denominator, they're both 5y, so I'm just going to bring that over here, and it's 5y. And then I can put together my numerators by saying this is going to be 3, that stays the same, plus 8 times 5y, because that's what we're doing to the top. So 8 times 5y is 40y. Whoop, 40y. Okay, and 3 plus 40y is 3 plus 40y. Okay, so that's my numerator. I can't factor anything out of that top, right? So I'm just leaving everything alone. I can't simplify that, so I'm good. Alright, so now I'm going to do the same thing with the bottom. I'll put it 8 over 1, and then same thing, I'm going to multiply top and bottom here by 5y, because I want the denominators to be the same. Oh, 5y, like so. And so I've got, this is going to equal, here's my fraction bar for the denominator, 5y comes across here, and then I've got 3 minus 8 times 5y is the 40y, and that's 3 minus 40y. 3 minus 40y. Okay? And now here's my problem, and now I'm going to, this is division, so I'm going to keep the top, change the sign to multiplication, and I'll just do it here. Keep the first one, first fraction, change the sign to multiplication, and flip this bottom one. So this is going to be 5y over 3 minus 40y. Okay, and what do they do here? So I can't factor anything out of this 3 plus 40y, nor down here 3 minus 40y. I can't factor anything out. So I can cancel these 5y's. They go into each other one time. So my final answer here is going to be 3 plus 40y divided by 3 minus 40y. And that's it. I'm done. Nothing I can do here to simplify that at all. These are not opposites. Okay, this is not 3 plus 40y over 40. I'm sorry, this is not 40 minus 40y minus 3. It would have to be. So this is it. I'm done. Alright, so that's similar to number 7. Now if you can factor something out, you would, and then do some canceling there if you can, but I can't. So don't force it. This is number 17, and again, it's the same concept here where I want to get these denominators to be the same in the numerator. So in order to, this is really over 1, if you need that. So in order to make this x plus 4, I have to multiply the denominator by x plus 4. In order to do the bottom, I do the top. X, that's x. X plus 4. Okay, bottom and top. Okay, 1 second here, I want to fix that. There, so it's going to be x plus 4. That's a little better. Okay. And I draw my fraction bar. I know my denominators now. My denominator is going to be x plus 4. And then the top is going to be 8 plus, and I'll do the distributive property here. 2 times x is 2x, and 2 times 4 is 8. So I got 2x plus 4. So this is going to be 8 plus 2x plus 8, which is 2x plus 16. Okay, I'm going to leave it like that for now. And that's going to be over, then I'll do the bottom here, the denominator. Same thing, put it over 1, got to make the denominators both x plus 4, so this is already, so I'll multiply this one by x plus 4. Do the bottom, I do the top, x plus 4. Okay, and remember I like putting it in parentheses. And what's that going to give me? That's going to give me a denominator here of x plus 4. And now my numerator here is going to be 12, and this is going to be, I'm going to distribute this. This is negative 2. So it's negative 2 times x is negative 2x. I'll squeeze it in over here. Negative 2x. And negative 2 times 4 is negative 8. Okay, so there's my new numerator for that part. And what have I got? 12 minus negative 8. 12, well, I don't do that. We use this one already. So it's 12 minus 8, which is 4. So I'm going to have negative 2x, and that's going to be plus 4. Because 12 minus 8 is positive 4. Alright, so there I am, keep, change, flip now. So this is going to be multiplied to the reciprocal of this. This is the one I'm going to flip. So it's going to be x plus 4 over this negative 2x plus 4. And then I want to do some simplifying here. So now this time I can simplify. So for this numerator here, see I have a GCF of 2. So I'll take the 2 out, and I've got x plus 8 left over. Okay, cross that off. And this denominator over here, I can take out the negative 2. And what's left is x minus 2. Okay, so then this one's gone. So now I want to do my canceling. These are all factors. 2 times x plus 8. This is x plus 4, and this is x plus 4, so these two will cancel. Right? So that's just going to be 1, and this is going to be 1. And then I got the 2's here. This is 2 over negative 2, which is negative 1. So I'll cancel this and put this as negative 1. So I've got a final answer here of this x plus 8 and this negative 1 times x minus 2. So when I write this, you know, I've got options here. I could write this as x plus 8 over, I could distribute that if I want, or you could write it as negative and put it as x minus 2. If you distribute the negative across, that would be fine as well, but you know, either way, they're the equivalent. So that's my answer for number 17. Okay, I hope that's clear enough. And you know, the beauty of video is you can watch it again a second time, make sure I did that right, and I'm sure I did. But that's it. So hope this helps, and let me know if you got any other questions. All right. See you, Clarence.